Hello maths fans, Dr. Tom Crawford here at the University of Oxford, and today I'm taking an Oxford admissions interview. I of course cannot interview myself, however I have found a very willing volunteer in the form of Alex from the YouTube channel Another Roof. If you haven't checked out Alex's channel before, I do strongly recommend the channel. It is fantastic, and we actually just recorded a video, which is now on the channel, where I was interviewing you.
Yes.
So this is now your chance to get revenge.
Yeah, you said I was willing to interview you. I'm eager, because think about how many students that Tom has terrified over the years. Just, you know, these innocent little students applying to this university, and you've put them through such an ordeal. But now, it's your turn. Well, you started me off on a horrible functions question, so we'll say let f be differentiable.
Okay.
Everywhere.
Mm-hmm.
And we know that f of x plus y is going to be equal to f of x times f of y, and we'll say for all x, y real.
Okay. Yep.
And then, given that f dash of 0 is 3, determine f of x.
Okay. So general formula for
Yep.
f of x, basically.
F of x.
Okay.
And we'll say it's a function from the reals to the reals on all that usual business.
Okay. Right, so we have a nice differentiable function, and we have this property. So that property is clearly going to be important, so I'm going to put a box around that to remind me to use it. You wouldn't have told me that unless I needed it. And I've got the f prime of 0 is 3. Right, so what can I determine from that? Interesting. So my initial thought, which I'm not going to go down, but my initial thought was, can I integrate from there? But of course, I'm not sure how much I actually know, given that I only know the derivative at a single point.
Yes.
Is kind of just to sort of talk through fully all of the thoughts flooding my brain right at this very moment. So what I'm going to try and do instead is basically differentiate up here and then try and get some relationship, because I want to kind of relate these two pieces of information you've given me, is again my process. So, right, so we've got f of x plus y is equal to f of x times f of y. So if I'm going to differentiate this now, now I might have to think a little bit about this. So I want to differentiate with respect to what? Ooh.
It's tricky, isn't it?
Yes, because I'm... So if I were to... Or could I substitute in a value maybe? That could help. Maybe that's going to help. So if I set... Okay, I might have an idea. So if I set y equals 0, then that tells me that f of x is equal to f of x times f of 0. Okay, so that's now going to tell me that either f of x is 0, but that can't be true because then f prime of 0 wouldn't be 3.
And why is that?
Because if f of x, because I'm thinking I want to cancel this, right? So I'm sort of saying if I cancel both f of x's, then I would get f of 0 equals 1. But of course, if f of x itself is 0...
Like 0 everywhere?
Yeah, I think so. So if the function is everywhere 0, then obviously its derivative has to also be 0. It can't be 3.
Yes.
That's what I'm thinking, right? So
that's good.
So I'm sort of, that's why, because I always worry about cancelling things that they could be 0.
Yeah, it's
okay.
Good to have your guard up about that. Yeah, that was, I thought you might not make that, so I thought that you might just jump in there and get f of 0 is 1 without considering that, because I think that's what a lot of students might do.
Yes.
So
I
had that planned as a kind of backup question. So did you make that assumption there?
Okay.
But yeah, well worked out, I think.
Right. So f of 0 is, well, I've the first part possibly right, because I've not got anywhere near the answer yet. So if f of 0 is 1 and f prime of 0 is 3, right. So where can I go from there? So f of 0 is 1, f prime of 0 is 3. Okay. Now, ooh, this is hinting at like a Taylor expansion type thing, maybe? Because I know the value of the function at a point, I know its derivative, but then that would be an approximation as opposed to the actual solution, wouldn't it? Put it.
I'm a pure mathematician. We don't do approximations here.
Okay, so no approximations allowed. Okay, okay. So I'm guessing that as a hint to not go down that route. So knowing these two things, can that help me? I think it can, because now if I set x is 0. No, but if I set x is 0, then that tells me that f of y is f of 0, which is 1 times f of y, so I get back the same thing, so that's not actually helpful. But I could set x to be equal to minus y. Okay, I don't know if this is going to help, but I'm going to try it. So if I let x equal minus y, then I've got f of minus y plus y, again to be clear, is equal to f of x, which is minus y, times f of y. But then that, of course, is f of 0, which is 1. Ooh, this feels like I'm getting somewhere. So now I can say, therefore, f of y is 1 over f of minus y. Okay. So I'm saying if I change... So when I change the sign of my argument, it's flipping and inverting. I think is what's happening here. I don't think I trust your face. I don't really know how to read it.
Nobody trusts my face. I think that's the wisest thing you've said so far.
And that would also satisfy what I had before. Maybe I can now differentiate this, but I don't know if that's going to help. All right, let me just write these things on the next page. I need more space. Okay. Is this all reasonably sensible so far?
This is all good stuff.
Okay.
I don't think this is the book solution, but I will say that this is how I did it.
Okay.
So it's been really interesting.
Yeah.
You did it a lot faster than I did. Actually.
Well, I'm not. Again, I haven't solved this yet. I'm just. I only asked because I just didn't want to go down, too much of a rabbit hole. That was all. And also, we all make algebraic mistakes, and it's good when we have two sets of eyes on our working. Okay, so I'm still trying to work out f of x. That's the goal. Now. So what could I do with this? So if I put in 0, I would just get that f of 0 is 1 over... Ooh. No, but that would just tell me that f of 0 is 1, which is fine. No, that doesn't tell me anything. Maybe differentiating is helpful, because I feel like I haven't used that yet. So I'm going to try that. I'm going to try differentiating. Let's see what I can learn from that. It might end up being a dead end, but... So if I calculate that, then I can say that f prime of x is... Oh, this is like a whole thing, isn't it? Okay, and so I've got f of minus x to the minus 1. So that's minus 1 over f of minus x squared. And then the chain rule says I'm going to bring out another minus, and then I've got f prime of minus x. I think, if I've differentiated that correctly. Wait, no, not. What am I doing? No, it has to be that. Yeah, no, I think that's right. I'm going to double check. So left-hand side derivative. So this is 1 over function. So that's definitely minus 1 over function squared. And then chain rule is derivative of function, which is definitely an f prime. And then I've pulled a minus out from the minus x. I think that's correct. So what can I learn from this? I can learn that f prime of x is minus minus becomes a plus, is equal to f prime of minus x divided by f of minus x all squared. God, is this even going to be remotely helpful? Possibly, because now if I sub in 0, now that x equals 0, Then I can say f prime of 0 is equal to f prime of 0 divided by f of 0 squared. But that's 1, so it doesn't tell me anything. Okay, so that's not helpful. Because that's just telling me, yeah, because that's just the same thing. Okay, so maybe I want to go back to the thing at the top.
So fortunately, that didn't really get you anywhere.
No.
I didn't want to stop you because I honestly I couldn't tell whether that was going to
Yeah.
lead to anything
You're like,
or
this
not.
may work.
Yeah, so I'm
Tom
really
go.
interested to see what comes out here.
Yeah. So it doesn't seem to give me any information. Okay. So I feel like this is really, really helpful. I feel like this is a very good discovery. But, so how can I plug that up there? So I could say then, so I can then say, actually subbing that into the top, that f of x plus y is f of x divided by, because I'm going to replace my f of y with my 1 over f of minus y, so that's over f of minus y. Okay, that feels a bit more interesting. Possibly. Now what if x was equal to y? That should be, because I tried x is minus y, so let's try that. So what if x and y are the same? Then I can say that f of 2x is equal to f of x squared. Right. And maybe now I differentiate. Again, I'm going to try it. I'm going to try differentiating it.
So I didn't try that, but it is, I will say, another clue as to what the answer is.
Yeah. I feel like I'm learning a lot, right? Because I'm learning that I've got like something up here about it's not quite symmetry, but there's some kind of inverse type symmetry thing. There's something here about doubling the argument is the same as squaring entire function. I feel like I'm learning a lot of information about the function. That's for sure.
Yeah.
And I could probably try and guess what it might be, maybe. I don't know, but I feel like there might be other things. Like at this point, I don't want to resort to guesswork.
Okay. You're not ready to guess yet?
I don't think so.
I started guessing a bit sooner.
Okay, no, that's fair enough.
But
right.
I also don't want to stop you because I'm interested to see where this might lead.
Yeah, I feel like maybe there's a few other things that I could learn about it. Okay, so differentiating that, I'm going to get a 2 f prime 2 of x is equal to, so I'm going to bring the 2 down, and then I've got f of x to the power 1, and then multiply by f prime of x. Right. And then x being 0, again, doesn't really tell me anything. No. Okay. So this one at the top is hinting at like a power type thing, actually, isn't it? Ooh, okay. It's not just like an e to the x thing, is it? Let me just throw that in and see if I can figure something out. So if I had like an e to the x, then e to the x plus y is definitely e to the x times e to the y. And then here, I'll worry about the numbers one's easy. That's easy to fix. It definitely satisfies that one. But then its derivative wouldn't work. But I could put a 3 up there and then differentiate and bring a 3 down. Feels like could be a thing. And then what's going on with this one? So if I had an e to the x, could I say that was equal to 1 over e to the minus x? It is, so that's also true. Right, I feel like it's some kind of exponential function. I don't know if it's an e, but it's...
Well, I don't think it's some kind of exponential function. I think it is that. You know, that's the function that satisfies all of those rules.
E to the 3x?
Yeah.
because it definitely satisfies that one.
Mm.
E to the 3x, because then yes, if I do replace x by x plus y, it is indeed that. Yes. Okay, I just wasn't. I wrote it down because I was like, I know that I'm going to have to pull down the 3 to get f prime of 0, but I hadn't sort of thought to actually check that.
Yeah. That was good. I think.
Okay, so there wasn't.
So there is, and I'll be honest, I didn't do it this way. I got to this where you've drawn the box around, and then I just thought I think I had the look to, and I think you had it in the back of your mind as well. The fact that you're making x negative and that's making it the reciprocal, that's where it kind of clocked, and then I just kind of guessed maybe that's it. And then it happened to be right. That
just tells you to put the 3 in.
Yeah, and then it kind of ticks all the other boxes. But it was really interesting watching you do the rest of it, because I was thinking, if you differentiate an exponential, that's kind of that is what's going to happen. So it's like, I didn't want to stop you from doing all of those things, because I was interested to see if there was another thing that you could work out, especially this whole f of 2x thing is f of x squared, because you can pull out the power.
That again that's going to be perfectly satisfied by
e to the 2 of 3x is e to the 3x all squared. So that was further than I got with it. But yeah.
Is there a sort of suggested solution where you don't have to just guess e? Like, do you get an equation where you're like, the only solution to this equation is e to the 3x or to e to the x?
So I can show you the
Yeah, no, I'm very interested to see this actually.
The book solution, if you will.
Yeah. No, I'm very intrigued.
It's still it still requires that leap where it's like the only thing that could satisfy it is.
Okay.
So
what bit was missing from the way I thought about it, let's say?
Well,
that's in the book.
Yeah, and I just want to reiterate, this is the book.
Oh, so no, by all means.
This isn't how I did it, but it is interesting, and the key is to use the definition of derivative.
Oh, like full on, like from first principles.
Yeah.
Okay, right, I see.
So what does that involve?
Well, now you've told me that. Let me see if I can figure it out then. Yeah. Sorry, I'm like hijacking my own interview.
No, that's yeah.
Okay, so we had that. So as in using this piece of information, or?
Yeah, you do have to use all of it.
So obviously f prime of x is the limit as h tends to 0 of f of x plus h minus...
It's probably better that you're doing this anyway, because your handwriting is far better on this iPad than mine.
Over h. Okay, so then if I now substitute in 0, ooh.
We've also got the other properties of the function, don't we?
And we also, that's how you do it. Okay, I got it. Now you just said it, I can see it immediately, because we're going to use the f of x plus h. Oh, that's actually quite clever. Is equal to f of x, f of h, by its other property. I see. So then, no, this is nice. I'm glad I asked about this.
It's always good to see the other ways, isn't it?
Yeah, no, absolutely.
Because I didn't think to use this, but as soon as you get started on it, you think, you can start to see the pieces fit together.
Because now it's f of x comes out as a factor times f of h minus 1. Yeah. And it's divided by h.
Yeah.
Right.
And then there's a bit of there's a trick here, which again I didn't spot.
Okay, let's think about this then. So as h tends to 0, so we do know what happens when x is 0, don't we? Yeah. So I can just sub in x is 0. And that will tell me something. Oh, I don't know if that's going to be helpful. I'm going to write it down anyway.
So f dash of x is equal to f of x times the limit of that thing.
Okay, that's right. Yeah, that does feel helpful. Right, so f dash of x is f of x multiplied by... I think I can see where this is going now.
It's helpful to know the answer, isn't it?
I was about to say, yeah, because I know what the answer is.
You know what that has to be, don't you?
F of h minus 1. So this has to be... Oh, I know exactly what... It's just, you could just use L'Hopital's rule. You can literally just L'Hopital's rule it, right? Because...
You really want to use L'Hopital's rule?
Well, I mean, most students I interview know it. Right, we don't prove it until like first year
That's
analysis,
interesting.
but
Yeah.
most of them have heard of it, so I would allow them to use it as long as they could tell me what it was.
Yeah, yeah.
But again, obviously, I guess you're not necessarily taught it at A level, so
Yeah,
whether it's fair game.
Yeah, and I think even if you are, you're not always taught the conditions for which, you're always told that it's a function that you can't, because you can only use it if the limit exists, right?
Yes.
Whereas sometimes it's just, oh, I'm just going to use it.
Because if I do use it, then I just get the answer, right? Because if I use it, then this limit is actually just the same. So if I state it properly. But I know the top is 0 and I know the bottom is 0. So a L'Hopital's rule can be applied when you have a 0 over a 0 or an infinity over an infinity.
Yeah.
So to me,
as long as the
feels
limit
like,
exists.
Yes.
Yeah. Which
we would hope it does, given
yeah,
that you've
yeah.
told me it's everywhere differentiable, so it has to exist.
Okay.
I'm going to argue that.
Give me that one.
Okay, so the limit is that, right? Because
This is nice, actually. I actually prefer this way of doing it.
yeah, because it doesn't rely on a trick. Because then it's the same as the limit as h tends to 0 of the derivative of the top with respect to h, which is f prime of h,
Yeah.
over the bottom, which is 1. But then now I can allow the limit, which is f prime of 0, which is 3. So now I have my actual differential equation. That's what I was thinking we'd get to. So now I can say f prime of x is 3 times f of x, and then you can do a separation of variables
If you want
argument if you really need to. But yes, that basically gives you a unique solution.
This is the thing that's very strongly implies that the function.
That's the answer, yeah.
Yeah, because what other function is where your derivative is a constant times the function? It has to be.
Yes.
Yeah. Should I show you the trick?
Yeah. What's the trick? What's the trick?
So it's here. This is to say, if you rewrite that as f of h plus 0, take f of 0 over h. So that is the definition of the derivative at 0.
Yep.
Which we know is 3.
I see.
So that thing
with that limit
boils down to 3. Your way is better though. So good.
Well, as long as you know L'Hopital's rule,
As long as you know
you
it,
say, and are able to explain.
But yeah, because this was the one thing that almost stopped me from using this question, because this is a good question. Obviously, it's good to ask you because you're more experienced, but I wouldn't give this to for that sort of reason where it's awkward. You never want to leave the student in a position where if you just don't happen to spot the trick, then they can't, because they're going to feel a little bit cheated out of this question, if you know what I mean.
But yeah, no, I do see your point. You don't want a problem that relies on a trick.
Yeah.
Right? Because you want to be able to sort of logically deduce things and try things.
Yeah.
You don't want it to just rely on do you or do you not know the trick. That's like an example of a bad interview question. I completely agree.
So,
but at the same time, I feel like you could hint at what that was in a way. You know, if you said, well, what is 1, and then if you replace that with f of 0, then it's beginning to look very much like, that. I'm just thinking, if I was doing this question, I would maybe get to that point, and if they were stuck, I would say, okay, well, let's replace that with f of 0, which we've calculated.
Yeah.
And then if you look at this and compare it to this,
I think if this was an actual...
And then you kind of point at them and you could...
Yeah, if this was an actual interview question, probably break it down like you did with the zeta function question, where you can have part A, part B, and then you can kind of steer them. So part A could be something to do with bringing this definition of derivative into play. And then it's kind of
checking, do you know that?
And then it's in your mind.
Yeah.
And then part B could be something to do with that, and then you're putting the pieces together. That's probably how you could do it.
Yes.
But yeah, excellent.
So that was fun. And thank you for showing me the textbook solution. So as again, I'm aware I just hijacked my own interview because I wanted to learn more about the problem because it was so fun.
But hey, if during an interview the student is so eager to sink their teeth into the question that they're going to hijack the interview and like, no, let me do this, then surely that gives you a good vibe that they're going to be a good mathematician.
Yes and no. Yes and no.
Yeah. Okay.
You know what? That was so much fun. I'm actually keen for a second question.
Right.
We'll see how. Yeah. I'm probably going to regret having just said that, but
a glutton for punishment.
Yeah, no, I enjoyed that. I enjoyed that, and I feel like it actually made me think a lot about how to design new and interesting interview questions. So please feed me more inspiration.
Okay, well, I've got a big number for you here.
Okay.
How many zeros does it end with?
How many zeros? Oh. How many zeros does 1,000 factorial have? All right, I think I've seen something similar
Okay.
to this, but that doesn't mean I necessarily remember anything about it. So let's. But
I'm interested to see your approach to this one.
okay. So I'm going to start by thinking about, well, what is 1,000 factorial? It's 1,000 times ... So it's 1,000 times 999 times blah 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 blah. Now, the ones I care about are the ones that end in zeros. I think are going to be the ones that are actually going to play a role here, because that's my theory. So let me just think about
And why is that?
because I think they're actually going to keep those zeros there because nothing else can happen. I think they have to end in a zero. Right, there's ... dots between all of these.
Yep.
But
we'll play fast and loose with the notation.
yeah. Good. Coming from a pure mathematician, I've converted. This is official. I've converted into the applied side right there. Fast and loose with the notation. But I'm going to just check this with a few simple cases. I think this is going to help me, but I could be wrong. So let me just. So if I had a small number, so if I was doing it with like 10, so obviously 10 times 9 times times 2 times 1. Now, I think I actually do know what the answer to that is. It's like 3.6 something million. Oh, but it might have more than one zero. Okay, maybe it does, maybe it doesn't. So it's 100% going to end in, if I take the 10 factorial, I definitely know it has 1 0 because it's some number times 10. So it has to have 1 0.
Agreed.
Now, if I have a number, let's think about this. If I have a number x and then I multiply by 20. Oh, but that, of course, is just 2 times 10 times x. So again, there's that. And the 2 doesn't matter because for the last digit, the 2 doesn't matter. Okay. I don't think. Okay. So I think that would still end in 1 0. Unless x ended in a 5. If x was like 5, maybe then it would still be okay. But if x... Wait, no. If x was literally 5, that would give me 2 zeros. If x was 15, that would give me still 2 zeros. Ugh. I'm going to just write some of this down. So that would be 2 zeros, number zeros. If it was 15, I don't know how useful any of this is going to be, but I just want to get a feel for the problem.
Yeah. Kind of, always a good thing to do, isn't it?
Playing around with it, yeah.
Yeah. You got to get your hands dirty, as we say.
So, and then if it was 15, you get 2 times 15, which is 30. So you're still getting 2 zeros, but then there's going to reach a point where it's going to be, if it got to 50, then it ends at 3 zeros. So, but that's because it already had one, because it itself was that. Ooh. So for every number that ends in oh, I've got it. I think I've literally just figured it out. He says, it's to do with how many powers of 10 are in the number. I think it's just that. It's just how many powers of 10 are in the number, because that'll tell you the number of zeros.
Okay.
So I think, okay, that's my current hypothesis. Okay. So, how many powers of 10 do I have? So it's 1,000 times, how many factors of 10? So there's lots of 10s there. The next time a 10 will come into play is going to be for 990 times 980 times, so they're going to be, each one of these Oh god, there's so many to try and count. Maybe it's easier to go from the bottom. Okay, so I've got 10 gives me a power of 10. And then I've got 20, 30, right down to 100. So all of these have factors. So obviously this one is just 10. This is 2 times 10. This is 3 times 10. Dot, 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 dot. This is 10 times 10. So I just need to know how many factors of 10 are in my number. But there could also be other factors within there that could pull together to give other 10s.
Where are those other 10s coming from?
Ah, okay, I've just figured it out, right. Because you can either have a 10 or you can have a 2 and a 5. So if I work out how many 10s are in this big long line of numbers and how many pairs of 2s and 5s there are, and it will be limited by the 5s because there will be more 2s, because every even number will have a 2. So I think it will be limited by the 5s because they have to come in pairs to give me the 10.
I think that's a very good.
Okay.
Yep.
God, there's so much to count. You said you liked combinatorics problems. So much to count.
Yeah, you give me the Riemann zeta function, I give you some counting problem.
So I'm going to start a new page. I need to get my head around this. I feel confident I have a route to a potential solution. Put it that way.
Yeah. I think you're on the right path, as it were.
Okay. So we want to know the number of 10s. So I'll think about that one in a moment. And I've also decided I care about the number of 5s because, as I just mentioned, every time there's a 5 and a 2, you're going to get a new 10, which gives you a new 0. However, I might also have to worry about hundreds. No, because the hundreds will be counted within the 10s. No, I think I'm safe. So the 5s will be less frequent than the 2s, and I have to have a pair. So it doesn't matter if I have, if I have like 64 2s and 300 5s, I can still only have 64 actual 10s. So I think the 5s will be less frequent than the 2s because the 2s will be in every other number for all the even numbers, and even higher, in fact. So,
are you at risk of over-counting here? Because every 10...
Oh, yes. When I say the 5s, I don't mean,
You mean
I'm
the
going to purposefully exclude like 10 and 20 and 30. I want like the ones that end in a 5.
Yeah. Okay, so the non-10 5s.
Yes, so I think
Okay.
I want
I think the way you're doing it is going to get you there.
but is it not
Yeah.
the smartest way to do it?
Let's see.
Okay, all right. Another 11, because there's that one as well in the hundreds.
Yeah, I was worried you were going to forget about that one.
So is it 211?
No.
Oh, God. because.
Yeah, you've done really well on this. Like I said, you've not gone necessarily the easiest route, but who cares? It's more about the process, isn't it? But where could there be extra things hiding in there?
This is the worst way ever to do this question.
Yeah, it's
so
tricky,
is it 235 then?
So
oh no, wait, because 625 is another 5.
That's 5 to the power 4, isn't it?
It's 236.
So yeah, the thing I've been sat here for the last 5 minutes trying to work out is that's not the answer, but I don't know why, because this does seem to make sense, doesn't it? I can't see where we've gone wrong. You're going to really hate me when I tell you the...
I'm very aware there's a much easier way to do it. I think I went down a rabbit hole.
Yeah.
Can you? Okay.
You've alluded to it. You've almost said it. What the quote unquote easy way of doing this is?
Prime factors.
Well, yeah. So the only way to make a 10, because we're basically counting how many 10s are in there.
Yeah. It's 2s and 5s.
And you've already said that there's an abundance of 2s.
And there's fewer 5s. So if I just know the number of 5s, then I know the answer.
Yeah.
So I think, therefore, the answer should be 249.
And that's it.
So now what I'm really intrigued by is where did we miss them on this earlier bit?
Because, like I said, for the whole back half of that, I was thinking, where have we gone wrong here?
So it's two. So we've definitely. Did I just add them up wrong? I might have literally just added them up wrong. Let's
I don't
just
think
check.
so, because when I was adding them up, I was thinking...
Because I've got the 200 here, right? I've done it in a weird way, but that's like the bulk 200 of the 5, 10, 15, 20, etc., etc., etc. And then I've realised...
You didn't account for the hundreds. And then there's an extra...
20?
There was an extra 10, and then another one because there's 11.
So there was the plus 11 for the hundreds.
That's
and
where
the
you got your
thousands.
211 from there.
And then you pointed out the multiples of 5 situation.
Yeah.
But then the 50s do count then, don't they? I think that's the point. I think when I...
Yes, that's it.
That's what it was, right? We basically can backwards engineer how my original thought process should have worked.
Yeah.
Knowing
the
answer.
It's easy to get the answer when you already know it. But,
of course, but no.
But yeah, I'm glad that we did that, because all the time I was sat here thinking, why isn't this working? Because this is a totally valid approach, but I couldn't quite see... But that's counting problems, isn't it?
I'm kind of glad this happened, in a way, because I think this is actually a really important lesson for people watching, because I have just done the classic thing of... I was like... The simplicity of it was kind of staring me in the face, but I had decided that I was going to count tens. Yeah. And so I was almost like too fixated on, I'm going to keep counting tens. When I had, exactly as you said, I had mentioned prime factorization, and I'd already realized that 5s were the key to the whole thing.
Yeah.
But I just hadn't quite, I feel like I just kind of, put my blinkers on and gone very much down this, I'm going to count tens.
Yeah, yeah.
And whilst we were able to eventually, show that it would have worked that way, it's so much harder because I can't keep track of what I'm counting as easily as I can if I just focus on 5s.
Yeah, but that's often the case when you're solving any problem, isn't it?
Absolutely,
you never solve it the easiest way first.
Yeah. No, of course.
The elegance can often come later. But
definitely.
yeah, good. And I think just good approach overall in both of those, where it was a case of, let's just get stuck in. You even said to me once, you looked at me and said, like, I don't know if this is helpful, I'm just going to get a feel for it. And I think that's the way you always have to attempt problems like this. So anyone who's going to attempt a real interview, that's probably a great piece of advice, isn't it? Where it's just...
I agree entirely. Yes.
Get stuck in.
Yes, but also keep track of what you're doing better than I did. That's also what there was too many bits going on. I think I needed to take a breather and be like, right, what am I actually doing here? Sometimes you can get with any maths problem, you get a bit too engrossed in it. So I think that was actually quite a nice example there of me getting too engrossed in the problem, and not, if I took a step back, I'd already figured out what the answer was.
My only other question for you is, would you get done for cheating going into an exam with all of your mathematical tattoos? Because you can't write on your hand, can you? But
believe it or not, the rule is you have to cover them with like tape.
Tape?
Well, or like something. So if I was in an exam where knowing Navier-Stokes was, part of the syllabus, which it probably wouldn't be, but if it was, then you could argue that I'm going in with a t-shirt, so I clearly just can't. But I think if I had it on my arms, then I believe I would have to, like, if this equation here was literally the exam, I would have to like cover it with tape or something.
Wow.
Or, maybe wear a long sleeve shirt that I wasn't allowed to lift up, or like...
Yeah.
I think that would actually be the rules, but...
I mean, it makes a lot of sense, but...
Alex, thank you so much.
Pleasure.
It was very insightful. It was fun. I definitely enjoyed it, and the first problem in particular, I think, was my favorite.
Okay.
Possibly because I maybe did a slightly better job of it in a way.
This is the difference between us. Give me a counting problem and I'm happy.
Yeah. I definitely am not a combinatorics fan. but I think I did feel like I learned a valuable lesson on that second one, actually, for me, and also hopefully for everyone watching, like in terms of actually taking a step back from the problem and realizing what's going on.
Sure.
It's something I preach, and I've just not followed my own teachings. So so that was actually interesting to see how that can affect you, as I say, in the interview setting. But it's been very good fun. So thank you for coming to Oxford. Thank you for giving me these interesting questions.
Thanks for having me.
Everyone watching, if you haven't already, do check out Alex's channel, Another Roof. I'll obviously link it in the video description, and I'll also add the link to the video on Alex's channel where I am interviewing Alex. So that one was recorded first, which is why we kept referring to this one as the revenge of Alex after I asked him some questions. But that
it wasn't much revenge though, was it, really?
Thank you to all of you for watching, as always. Please do remember to subscribe to the channel if you've enjoyed this, and I will see you soon, and I'm sure Alex will also see you very soon over on his channel, Another Roof.
Thanks for watching, guys.